A very good morning, class 11. So in this video lecture we will study your chapter 13 of your NCERT, which is your hydrocarbon. So now let us understand hydrocarbons. So basically hydrocarbons are the compounds containing carbon and hydrogen only. These are obtained mainly from petroleum, natural gas or coals, and these hydrocarbons are very important source of energy. For example, we are having important fuels like petroleum, kerosene, coal gas, oil gas, CNG. So all these fuels containing mixtures of hydrocarbons which are source of energy. So means we can say that these hydrocarbons plays a very important role in our daily life. So now let us discuss types of hydrocarbons. So basically we are having three types of hydrocarbons, in which first is your saturated hydrocarbon, next is your unsaturated hydrocarbons, and the last is your aromatic hydrocarbons. So let us understand saturated hydrocarbons at very first. So basically the hydrocarbons which containing only carbon-carbon single bond are called saturated hydrocarbons. As we can see over this particular slide, we are having only carbon-carbon single bond over this compound. Similarly over the cyclic compound, what we are having only carbon-carbon single bonds. Okay, so means all these type of compounds which contain only single bond, okay, these will be termed as your saturated hydrocarbons. So second we have unsaturated hydrocarbons, which consist carbon-carbon multiple bond, and it could be double or triple. As we can see over this diagram, what we are having this carbon-carbon double bond, and for this particular compound we are having carbon-carbon triple bond. So all those compounds which consist either double bond or your triple bond are termed as your unsaturated hydrocarbons. And the next is aromatic hydrocarbons, which are those hydrocarbons which contain at least one special type of hexagonal ring of 6 carbon atom with 3 bonds in the alternate position, and basically this ring is called our benzene ring. So as we can see over this slide, this particular ring is known as your benzene ring, and this whole complete molecule is your toluene, which consists a methyl group over your benzene ring. Similarly, we are having naphthalene molecule over there, which consists how many rings? 1 and 2 benzene ring. Similarly, for the anthracene, we are having 3 benzene ring. So all these compounds which consist at least one benzene ring in itself are termed as your aromatic hydrocarbons. So now let us understand alkanes. So basically alkanes are saturated hydrocarbons containing only carbon-carbon single bond, and these hydrocarbons are also known as paraffins, which are further categorized as acyclic alkanes and cyclic alkanes. So let us understand these acyclic and cyclic alkanes one by one. So the acyclic alkanes, or we can say the open chain alkanes, are simple alkanes without any closed chain, means they are having open chain structures. As we are having this methane molecule over there, which consists only single bond and having its general formula CnH2n plus 2. If we put the value of n equals to 1 over there, so we will get this formula of your methane. So next we have cycloalkanes, which contain a closed chain or ring in their molecule, and they are having the general formula CnH2n. As we can see over these slides, we are having these two cyclic structures. So these are cyclic in nature, that's why they are termed as your cycloalkanes, which consist only carbon-carbon single bond. As you can see over this cyclopropane, we are having only carbon-carbon single bond, and this is a ring structure. Similarly over the cyclobutane, we are having only single bond between the carbon atoms, and which consists your cyclic structure. So that's why they are termed as your cycloalkanes, or you can say cyclic alkanes. So let us understand the nomenclature of alkanes, means how we will name all these alkanes. So its first rule says that we have to go for the longest carbon chain. Okay, means we have to select the longest carbon chain within the molecule. As we are having this particular compound, so we have to select the longest carbon chain. So over this particular compound, this is our longest carbon chain, which consists of 9 carbon atoms. And one thing you have to focus, that this particular longest carbon chain is termed as your parent root chain, and the carbon atoms which are not included in this parent chain are called your substituents. Okay, so these carbons, means we haven't included this carbon and these two carbons in our parent chain, so these two carbon atoms will be termed as your substituent. So we are having this substituent as well as this is your substituent. So the second part of your nomenclature is the position of substituents. So means you have to mention the position of these substituents, means where they are situated. So what we do, we go for the numbering of this parent chain, and we have to keep in mind one thing, that the numbering is done in such a way that the branch carbon atom get the lowest possible number. Okay, so next rule of nomenclature is regarding the presence of more than one same substituent. Means if in any compound you are having more than one same substituents, as we can see over there, we are having this methyl and this also is methyl, and these two are same substituents. So for the same substituents, what we do, we use the prefix di. If we are having two substituents, so we will use dia, and if we are having three same substituent, we will use tri, and same if we are having four, then we will use tetra. So over this particular compound, what we are having two methyl groups, so we will use 2,4 dimethyl, and the parent chain is of 5 carbon atoms, so we will say it as pentane. So our complete name of this particular compound will be your 2,4 dimethyl pentane. So the next rule is regarding the naming different substituent. So here we are having the different substituents. So here we are having this ethyl group, and these two substituents are your methyl group. So if we are having different substituents, so what we have to do, it says if two or more different substituents or side chain are present in a molecule, they are named in a alphabetical order. Means we have to name them in according to their alphabetical order. So this is your ethyl and this is your methyl. So E come at the first, so we will name it as 3-ethyl. We have just mentioned the position of this ethyl group, so it is situated at your third carbon. So we have mentioned 3-ethyl and 2,3-dimethyl pentane, because the position of your these two methyl groups are at over second and third carbon. So that's why we have mentioned 2, 3, and both are similar. Okay, so that's why we have put dimethyl. Okay, so the complete name of this particular compound will be your 3-ethyl 2,3-dimethyl pentane. So our next rule is regarding the naming different substituent at equivalent positions. So here what we are having two different substituents. We are having this ethyl group over there, and this is your methyl group, and how we have to name these compounds. So what we are observing, that if we go for the numbering of this carbon chain from there, from your left to right, so this particular methyl group contain your third number, and this particular ethyl group consists your fifth number. Okay, and if we are going for the numbering from your right to left, so what we are observing, we will be having this ethyl group as third number and this methyl group at fifth carbon. So how do we name these particular compound? Either we go from this side or from this side. So it says if two different substituents are in equivalent positions from the two ends of the chain, then the numbering of chain is done in such a way that the group which come first in alphabetical order gets the lower down. Means you have to give lower number to that particular substituent which come first in the alphabetical order. So between this methyl and ethyl group which come first according to the alphabetical order, obviously this ethyl E comes at the first, so you have to give the very lowest number to this ethyl groups. So means you have to go for the numbering of this particular chain in this way. You have to move from your right to left. Okay, so this is your perfect numbering and this is your wrong. Okay, so how we will name this? So we are having this ethyl group at which carbon? Third carbon, so that will be your 3-ethyl, and we are having methyl group over this fifth carbon, so that's why we will be having 5-methyl. Okay, so what will be the name of this particular compound? That will be your 3-ethyl 5-methyl heptane, because we are having 7 carbon atoms over there. So these are the few sets of rules which we have to keep in mind during your IUPAC nomenclature of your alkanes. Let's move further. So let us understand the preparation of alkanes. So basically we can prepare these alkanes with the help of your unsaturated hydrocarbons and from alkyl halides and from your carboxylic acid. So let us discuss them one by one. So the unsaturated hydrocarbons, like we are having alkenes and alkynes, are converted into alkanes by catalytic hydrogenation, and in this process dihydrogen gases pass through the alkenes or alkynes in the presence of finely divided catalysts, such as you are having nickel, palladium, platinum you can use as a catalyst, and these metals absorb dihydrogen gas on their surface and activate the hydrogen-hydrogen bond. And platinum and the palladium catalyze the reaction at room temperature. However, higher temperature and the pressure are required with nickel catalyst. So what we are doing over there, we are doing the catalytic hydrogenation in the presence of these catalysts, and which results in the formation of your alkanes. So next method of preparation is from carboxylic acid, and from these carboxylic acid we are having two methods. One is your decarboxylation reaction and the second is your Kolbe electrolytic method. So in decarboxylic reaction, what we do, we used to take your sodium salts of carboxylic acid and on heating with soda lime, and basically your soda lime is a mixture of your sodium hydroxide and the calcium oxide, and which gives alkane containing one carbon atom lesser than your carboxylic acid which you have used. And in this process of elimination of carbon dioxide from the carboxylic acid is known as your decarboxylation reaction. Okay, so as you can see, we are having this sodium ethanoate over there, and we have used this particular mixture which is known as your soda lime, in which we are using your NaOH and your CaO. Okay, and which results in the formation of your this methane and your Na2CO3, which is your sodium carbonate. And the next method is your Kolbe electrolytic method. In this reaction, we are using aqueous solution of your sodium or potassium salts of your carboxylic acid. On electrolysis of these sodium and potassium salts of these carboxylic acid gives us alkane, which contain even number of carbon atoms at the anode. So as we can see, we are having the sodium acetate, and we go for the electrolysis of this particular compound. So it results into the formation of your ethene and with the liberation of your CO2 gas. Okay, so this is your Kolbe reaction. So that was all about your hydrocarbons, where we have understand what are hydrocarbons, their classification, and understand alkanes in details, their structures, their nomenclatures and preparations. So students, that's all for this video. Hope you enjoyed this video, and thank you so much for listening.